Okay, so we've got a bracket design. Let's make, so if you can see this, you can see how this is going to bolt onto that boss, and then on this will have the bolt that goes down through the caliper hanger. And our distance from here to here should be 560. We can check that. The measuring on Fusion is a little bit odd, but that gives us, we're in metric. So it's 14 millimeters, which is 555, which is about what it was. We were going for 560, right? Okay, and let's switch to out of metric into inch. Just because my machine reads inch, actually it will read either, but sometimes if I need to modify something, it just makes, let me have some tea and I'll get back with you. Just as easier sometimes. Okay, so our setup, let's do a new setup. And I think what I'll do, since this is a flat plane, we'll use this time. I always struggle with this whole thing. Okay, so the nice thing about this is the way we designed it, our Z is already up. So sometimes when you design something and then you're trying to lay it out, I have to screw around with it for 10 minutes to get the coordinate to work right. And I don't really know, and I'm sure it's something that I'm doing wrong, but it's very frustrating. Let's get rid of the extra stock because we don't really want to do the extra stock. That's about where we want. So as you can see, this is our three axi, our Z and X and Y, and that's the way the machine is laid out, so that'll work. Let's run with that. And then let's do, since it's contoured, let's do an adaptive clearing. And I think what we'll do is use, I've got a 3/4, not 3/4 in there. It is a number 8. Where are you? Number 8, 3/4, right there. Okay. So these all look okay, very conservative feed rates, but we're just doing one piece and it's a demo kind of thing, so we'll just leave it the way it is. Get rid of the rest machine, stop contours. Let's see how this looks. Okay, it almost went around. I'm thinking maybe if we put some stock back in here. Let's go 0.25. Actually, we've got a kind of a big chunk of material, so we can add a lot. So let's try that again. Generate toolpath. Okay, that's all right. That'll work. And this adaptive clearing just does some crazy toolpaths. It just, you know, I think it figures out the load on the tool, so it is always taking a percentage of what the tool is. The old school, it used to just go line to line to line, and there are times where you would be, you know, 30% of the tool would be in the material, and then you would run it right into a full 180 of the tool, which would then, you know, cause the machine to stall or stop or chatter or whatever. And so I think they've smartened this up, and so it's always, but it makes for crazy tool paths. So that will give us kind of a rough place to be. It seems like we're a little bit much material, but you know what? I'm not going to worry about it. Let's make sure we've got, yeah, we're leaving 20 thousandths. Let's make that step over of 300 instead of 390. Okay, and I think that will do for that first roughing pass. Okay, let's do a contour 2D contour for the center, and we'll choose a 1/4" end mill. Now a lot of these tools are already in the machine. So I already know where they are. I don't really have to figure that out. We're going to go down 0.6. I'm just going to throw that out there. And let's make multiple depths. 0.125. And we want to ramp it. Okay, let's see how that looks. Alright, and that's going all the way through. The ramp, I think, will be okay. I think that looks alright. Why do we have a little caution? Lead out is dropped due to linking constraint. Alright, whatever. That's fine. I don't care. Okay, and then we're going to drill some holes. So we want to do a 255 drill, which I should have. Where? Right there. Tool 5. It's already in Tool 5. I seem to use a lot of M8 holes, so we want to select our bore. But I want to go way deeper, so we've got enough room for the tap to go through. And I'm going to do, I always do deep hole drilling. I always want it to retract. Sometimes it's a waste of time, and if I was making 8 million of these, then yeah, I would optimize it and maybe get a really super fast carbide drill that just blasts through in one shot, but I'm not, so I'm not. So let's do that. Let's check it and see. That shows that it's going down and through, so that's good. Let's do a tap, which is a 312 and number 6. That works. That works. Then we can just do that. And let's put an extra 100 thou in there. Whoop, not an equal. 0.1. Okay. That does that. That does. Okay, so we've got that. My eye is itching, and I don't know why. But let me scratch it. Maybe I need some tea. Let's go with some tea. Okay, so we've drilled and tapped, we've got our slot, we've got the surface roughed in, so let's see if we can get, you know, maybe we can do, let's do this contour with our 1/4" end mill. And sometimes this goes wonky. That's not going to give us what we want. Okay. Yeah, not even close. Okay, let's try this. What about if we did get rid of stock contour? How about rest machine? And that's not going to do anything. Okay, let's okay, if we do it's almost workable, isn't it? No. It's gonna run into it there. Alright, let's leave it for now. You know what I'm gonna do. And here's where I start cheating because I don't really know how to make this happen. Is let's make we'll construct a plane off of that surface, and we'll go down 0.2, and that should get us all the way through. We'll draw a plane and a box. come over here, create extrude, and then we'll just go up. That didn't quite get us all. So let's try to get it all the way at least to that tangent point. So we can just go back here. And let's go 3. Except for I don't want... Let's get rid of that. We'll just suppress that, the counter bore, because we don't really care at this point. Okay, that should give us enough room. Okay, so let's draw. You know what we could do is an offset, and we'll go 3/10, and then draw a line over here. And extend that, and extend that. And trim you, and trim you. Now, is there other ways to do this? Probably, and probably way smarter ways, but this is the way I get around stuff if I can't figure out how to make it happen. So, this is how we're going to do it. Let's get rid of you, and then we'll make it that contour. Why did you fail to generate? Cancel. Is it because we cut away the top portion of this, so our setup is different? Maybe. Let's go back, and we can turn all of those off. Okay. There we go. Let's go down further. So it still picked up that same contour, even though I added the material back on, and it's not showing it. And it's really kind of suppressed. Not really sure why. Okay, that'll work. Okay, that will get us around there. That'll be good. That'll be good. Let's do a parallel cut with a 9/16 ball. And we can do that. And we're gonna we don't want to touch those surfaces. No. Stop. Alright. Cancel. Okay. Let's do this again. Not you, you. Okay. We want to avoid you, you. This thing is, see, sometimes it's so touchy, and then there's no way to fix this. Sometimes you can just go, oh, there we go, almost got it. So I can go back and delete them all. They haven't worked out all the stuff on this yet. Or, I don't know what I'm doing, which very well could be a combination of both of those. Okay, let's try that. No? Okay. Generation was completed successfully, except for it was an empty toolpath. Why would they bother to tell me that? I don't need to hear that. silly program anyway. Okay, let's see how that looks. No. Okay, let's try that. Okay, that looks like it will do okay. Our face will already be faced off because I'm just going to face that off manually till I get it where I want. I think we're good. So let's try, we'll highlight all those. Not yet. Let's do this. We want to do shaft or stock. Let's see how that looks. I think we're going to end up cutting some air because the block isn't quite that big, but I'm not sure I'm going to change it. I think that looks okay. Maybe we make this step over on that parallel a little bit closer. Let's go 1/8 thou. Okay, what's this little thing right here? Must be that we didn't choose that. Okay. Is that it? No, we didn't get that one. Okay. Okay, looks good. Everything looks good. Our contour looks good. You know, let's do this in 2 steps though. Multiple depths. Let's go 0.3. There. And we're not trying to take it all with one shot. Okay. Generate the tool path. We're going to use 105 and bracket first, post. So we got to transfer it into the other laptop. I really need to set up the wireless, but I've never done it. And so I continue to use what works. So we're going to open that up and use that. So here's the machine code. Tells us our tools, and this is the machine code that the machine reads to do what it does. I used to write all this by hand. It's so much nicer to be able to do this. Now there's a couple of things that this post processor doesn't do, and I don't really know how to go in. I need to at some point figure out how to go in and add these features, but I like to turn off the spindle every time. Oh, G32. So I'm going to add an M5. And all this does, this means it stops at the end of this tool. And if I'm not over there, it will stop at the end of the tool and it'll leave the spindle running. And oftentimes if I'm over welding or doing something else and the spindle is running, it drives me crazy. So I just shut the spindle off in case we get there. So we'll turn that off, that off. And then I get rid of the return to X, so it's just returns up the Z and the Y. And that's all we care about with that. Oh yeah, we need to change our tapping cycle. Okay, our drill cycle looks okay. Let's put that at 89. We'll go a little bit deeper. That's fine. Our feed rate's too high. Let's set that down. And then our tapping cycle. This is a most generally, every machine I've ever run uses a G84 for a rigid tap. My machine runs a G88. I don't know why. Miltronics just did it that way. And then we'll get rid of that.